Okay, so now we see the equation of a line can be expressed using this slope-intercept notation, where you just have the slope and you have the y-intercept, and then you have y equals mx plus b. This is one of my favorite ways of writing lines, by the way. So m represents the slope, and b represents the y-intercept. Fantastic. Okay, but now suppose that I asked you to find the equation of the line that actually passes through 2 points, and that's all you know. I don't tell you the slope, I just tell you the 2 points. So let's do a first example here. So I want you to find the equation of the line that passes through 0, 3, and also 2, 2. Okay, now let's think about that. Well, first of all, 0, 3, and 2, 2. I want to find the slope. I need the slope. So what do? Well, that's just the change in y. That's the change in y. I'm going to write it in the shorthand notation over the change in x. So I've got to subtract the y from the y and then the x from the x. And always remember, subtract in the same order. Y from y, x from x. If you don't like that, you could do it this way. Now watch this. This is different. Y from y, x from x. Either one's correct. But what's bad would be y from y, x from x. That doesn't even feel right if you just do it physically. You want to go y from y, x from x. Okay, let's do it that way. So let's go y, that, minus that. So 2 minus 3, and divide that by 2 minus 0. So that equals minus 1 divided by 2, which equals minus a half. So the slope we immediately see is minus a half. That was pretty easy. So that's just that goes in there. Now what about the y-intercept? Well, that's where the curve is going to cross, the line is going to cross the y-axis. That means that x would be 0 there. So that's where x is 0, because that's the y-axis. And if you notice, look at that, 0, 3. That means we go 0 in the x direction and just up 3. So in fact, that's the y-intercept. Y-intercept is hidden right there. So in fact, since this is a 0 comma something, that's the y-intercept. So I can just immediately say y equals minus a half x and then plus 3. So that was really easy, because in fact they gave us the y-intercept. We just had to realize that that was the y-intercept, because x is 0. So if x is 0, that means that 0, 3, that's the y-intercept. Okay, let's try one where in fact the poser of the question wasn't so friendly. So let's find the equation for the line, and let's do it in slope-intercept form. So I'll remind you what that is. If the line contains the following 2 points, one of them is 1, 2, and the other one is minus 1, minus 4. Well, of course, we're going to need the slope again, so let's compute that. So slope equals the change in y over the change in x. So remember, we can subtract this from this, or this from this, and this from this, and you can get the idea. Let's do the following. Let's take this and subtract this. So that's going to be 2 minus minus 4. And I divide that now by 1 minus minus 1. So you have to be careful with all those negative signs. Those negative signs actually combine to give a positive. So in fact, that's 2 plus 4, which is 6, divided by 1 plus 1. You might think 0 here, but be careful. It's 1 plus 1, which is 2. So this has slope 3. So that tells us what the slope is. So that's pretty cool. Okay, but now what I want to do is I want to find out the y-intercept. But you'll notice neither of these points are an intercept. This is 1, 2, and this is minus 1, minus 4. So it looks like I'm in trouble here. However, if you think about it, 2 points should determine a line uniquely. So if I know 2 points, I should be able to find the equation of the line. I already found the slope. I'm missing this value here. Well, the way to proceed is to actually put in what you have. So I have y equals 3x plus b. And the question is, what's b? That's the question. What is this? Right? That's the question. But what do I know? I know that both of these points lie on the line. That means that both of these points must satisfy this equation. If I plug in 1 for x and 2 for y, this must be satisfied. So all I have to do is pick one of these points and plug it in for x and y. Let's do that. Let's take this point here, and what I'm going to do is I'm going to take that 2, and I'm going to plug it in for x, and I'm going to take this 1 and plug it in. Oh my goodness, I made a huge typo. Sorry. This 1 is the x value, so I'm going to plug this in for x, and then this 2 I'm going to plug in for y. Okay? So I'm going to take this point that I know has to satisfy this equation, and I'm going to put this in for x and that value in for y, and that has to be true. But what would it look like? Well, here I'd see a 2 equals 3 times 1 plus b. I still don't know what b is. But look, now I have an equation and I can solve for b. So by taking one of the points that I know must lie on the line and substituting it in for x and y appropriately, I will have an equation that just has b and everything else is known to be a number. And so I can solve for b. In fact, in this case, I see that 2 equals 3 plus b. So if I bring the 3 over as a negative 3, I see that b must equal negative 1. So I actually can find the y-intercept, even if I'm not given it, by just taking one of the points and putting in. By the way, if you would have taken this point and plugged it into here, you would actually get the same answer for b. And you can try that. You can take minus 1, minus 4, plug in the minus 4 here, plug in the minus 1 here, and solve, and you'll still get minus 1 for b. You can try it. Anyway, armed with that, I now see that the equation of the line is y equals the slope, which is 3x, and then plus b, and b here is minus 1, so I'll just put down plus minus, or just minus 1. And there's the equation of the line. So just given 2 points, I can now find the equation of the line, and I'm writing it in the slope-intercept form. Neat-o! All right, you try some of these, see what you think.